Okay, so I think we waited 2 minutes, so I hope all of you are prepared and ready. So let's go straight to the presentation for today. Okay, so again, good morning, good afternoon, and good evening, ladies and gentlemen. The As you all know, the topic for today's webinar is multi-scenario field development planning for max economic efficiency, and we are going to go through what exactly is a multi-scenario development planning, or MSDP for short. So MSDP really is an interactive field development planning facility. Basically, it simulates what should be the typical asset behavior if the asset team tries out some different development options, and they can run through year by year field production options in a very short time. And based on the results that they get and the metrics that MSDP outputs, they can select the optimal production and surveillance strategy, which is based as well as on economics. So the objectives are two that we have. The first one is to create the optimal FDP, which has a maximum immunity to the current field uncertainties. And secondly, we also want to design a fit for purpose surveillance strategy to support the optimal production. Because when I go on further, you'll see that the R software is also able to simulate the field sensors and the results of the field sensors. So that is also something that can be done. So if you look at the normal FDP workflow, generally you will have a geoscientific team where you have a geologist, geophysicists, your reservoir engineers, production engineers, your petrophysicists and log analysts. Then you, for sure, they will all be working under an asset manager. And then there are facilities and FDP engineers. And last but not least, the simulation engineer, who's one of the key persons in this work. So generally, the asset team is going to say that we have a 3D model and we are going to analyze the current distribution of reserves and pressure, and then identify those areas from where there's more reserves and when there's a good pressure and we can get more production from them. And then they'll try to generate the production forecasts. Basically, I mean, you may have two or three 3D models, maybe one with a high STOIP, one with a low STOIP, one with a medium STOIP. And then, depending on these, many companies may say we are going to design three FDPs. One is a low capex, and one is a medium capex, and one is a high capex. Then the financial analysts go to work and you calculate the P&L, which is presented to management along with the scenarios, and then one particular FDP is approved. So that's the conventional process. But with MSDP, so here you can see this is a flow chart of the conventional process. You may have like three different models. Then you have a simulation engineer who's told what is the FDP options, and then he converts them into the simulator language. And for maybe three scenarios, maybe a low capex, a middle capex, and a high capex. And then based on that, the optimal plan is identified. So this is, of course, the conventional and very rigorous process, and it can take quite a bit of time, even up to a year. And we see that the simulation engineer is the person who's taking the most all the load on his shoulders in this situation. So with MSDP, what we try to do was to try to involve the FDP group and the asset teams also in this actual development plan selection. So basically, your FDP group and the asset team will sit together and they look at different development scenarios. Uh, and those scenarios normally would be given to the simulation engineer, and then he will go and convert those to the simulator language and then run the models and see the results. But in this case, what we've done with MSDP is that we've made a web interface to the reservoir simulator. What we call Polyplan is the commercial name. And so the different scenarios can be inputted directly into Polyplan by any of these members of the asset teams. Then Polyplan runs the simulator in the background, and it pops up the results in the form of graphs and tables, as you can see here. So it will output graphs like these are the production history and production forecast for the field, which includes the oil rates, the liquid rates, the injection, VRR, stuff like that. Then it will output a financials table, which will cover the NPV and the budgets. It will analyze how the asset team is using the budget, like which percentage of it went to producer drilling or injector drilling or workover, stuff like that. And it will also do an activity by activity analysis of all the different FDP activities. So, for example, it'll see how many producers drilled, and the total rate on the new wells, uh, the water cuts, pressures, product PI, all these kind of tables are output automatically by MSDP. And then based on these, for the different scenarios, the asset team can decide to select the optimal plan. What we mean by optimal is the one which has the lowest risk over all realizations. So basically, if we see that drilling a well in a particular part of the field gives good results, no matter which model we use or scenario, then that's definitely going to be part of the final FDP. So let's talk a little bit about the Polyplan software itself. So as I mentioned, it's a web interface. So when you click on Polyplan to start it, you'll get a window coming up like this. So in the middle, you'll see the location map with the wells, and it's color coded according to different parameters. So, for example, the oil in place. This map can be zoomed in and zoomed out. And if you click on any particular point of the map, it will give that X and Y location. Then there's also an online data room. So if any team member clicks on the data room, it'll go straight to the data room where it has all the data about this field. So like your seismic data, your well logs, your say PLTs or formation pressures, your cross sections, your log sections, all that information is there on the online data room, and any member of the team can click on it and see the data online. So there are different options available, starting with new well or workovers or perforation and production targets. So let's say now we're going to suppose we're going to drill this, we're going to do this FDP over, let's say, 7 years. So this Polyplan is going to make the FDP year by year. So every year in our terminology is called a shot. So the first year FDP is called shot number 1. So that's what this is telling you, that this is shot number 1 out of 7, where we have a plan for a full 7 years FDP. And as we mentioned, that the economics is very important. So on the top right hand side, you'll see the budget that's also available. So we started off with like this is 1.4 million or so, and then let's see what it takes to drill a new well. So we'll start drilling the new well. So to drill it, we need to zoom in on the area of the um, map where we want to drill the well, and we click. Once we click, then the polyplan will automatically tell us the x and y coordinates. So then we'll enter the wellhead coordinates, the coordinates of the heel and the toe, as well as the length of the well. So in this case, you see that this is a vertical well because the heel and the toe are at the same location. But we can also drill horizontal wells with this. And as soon as you enter the details about the new well that you're going to drill, Polyplan will automatically calculate what's going to be the cost of the well. So it says it's going to cost $661,000 here to drill this well. So if you call out, then that much money is removed from your budget, and you will get the remaining money out of after drilling that one well. Right? So now, when you drill a new well, Polyplan will automatically simulate the open hole log for that well. So you can look at that well and look at that open hole log. You can pick out your zones of interest, and you can take pressures on those zones. Then you can perforate the zones that you really want. Also, for example, if you see that some particular zone looks good but it may be tight, if we look at our porosity permeability relationship, which is there inside the data room, then maybe you can fracture that particular zone also. You can put in multi-stage fracks. Then you can do case hole logging. And finally, a very important step is to commission the well. So that's for a new well. Then you can do workovers. So workovers include stuff like water shutoffs or stimulations or even frac jobs. Then you can add perforations in existing wells. Then another very important thing is the production targets. So for all of these wells in the field, you are required to set the production target, and then the simulator will run and decide how many of those targets can be followed and how many of those may not be followed, right? So that's just a quick high-level view. Let's go in a little more detail. So as I mentioned, it has an input response simulator. So let's say we drilled a new well, then as soon as you go to the data room, Polyplan will, MSDP is going to recreate the expected logs for that well. So here you can see that this is my zone of interest. This could be a good zone. I can see the neutron density logs. I can see the gamma ray. These are the resistivity. Then at this point, I can take pressures across these zones. So maybe I find that one zone is actually lower pressure than expected. Maybe it is depleted. So maybe I will not perforate there, but I'll perforate another zone. So these are the things you can do in real time with MSDP. Also mentioned there's a field sensor simulator. So let's say you have an existing well and you see that suddenly the water cut has gone off a lot. So I say, let me run a PLT on this well. So then you'll run the well and it will give you the simulated PLT from this well, and you can see which possible zone may be watering out, right? Or you could even simulate channeling behind casing based on the pressure drawdown and stuff like that. You can look at pressure buildups, and again, these are the open hole logs which you can see. So that was the field sensor simulator part of it. And then finally, once you've decided all your actions for the first year of development, for the first shot, then we say take shot. So that means all the actions that you have, they have been put in a queue. And when we say take shot, then MSDP goes and runs the simulator in the background. And depending on how much time it takes to run the simulator, At the end of that, it's going to give you your results like the oil rate, the water cut, injection rate if it's an injector, and the pressure in the well, stuff like that. And then at the end of every shot, there's also an output server. So the output server again, it sends data to the data room. So it's going to so for shot number one, we ran the simulator, and this is the field response. So you'll see your oil rate, your liquid rate, your water cut, then the VRR, injection rate, stuff like that. This is for the whole field, and it will also plot well by well. So here's an injector, so you can see injection rate. Here's a producer, you can see the production rates. So these are the kind of information it's going to give you after every year that you develop. And then you can go in and see, okay, I thought I'll drill this injector here and the pressure would go up, but actually the pressure around that injector is going down. So what's the reason? And or maybe the water cut suddenly went up too high in another well, and different kind of observations that you make from this you can address in your shot number two, which is the going to be the FDP plan for the second year. Although, if you recall, when I showed the first plot, which was um, the base map and stuff, there was an option to do undo and reset. So while you're doing the shot number one, you can also undo and reset your actions. And if you see that it's not, maybe I drilled the well, but I find that there's nothing there. So I can undo that drilling option and I can drill a well in another place. So there are many options in MSDP. And then finally, of course, there's economics inside it. So, as I said, the budget for the first shot is specified. And like every company, we know every year we have a budget, and it's only out of all this budget that I can do my different activities. So, for example, the company can say that you have $3 million this year. And then after that 1 year, what you have is what's the remaining balance from what you spent, plus the money you get back by selling your oil and hydrocarbons. And so, of course, you have to put in an expected price, a yearly price on this, right? And then in MSDP, we specify what are your OPEX numbers and CAPEX numbers and stuff like that. So based on that, you see how much money you spent in the first year, how much money you have left, and how much money you earned by selling your crude, and that decides what's going to be the budget for the second year. So that was, in a sort of nutshell, what MSDP and Polyplan was about. So basically, as we saw, that you have one or more dynamic models to account for the uncertainties. Like you may have a high STOIP or middle STOIP or low STOIP. So, for example, like if you are not sure my porosity permeability transform, maybe I have two options. So maybe you would have two models based on different porosity transforms. And then for each model, we saw that we can drill wells, we can do workovers, we can optimize the production and the injection, we can run PLTs and pressure buildups and stuff. We can specify the rates, and we are also looking at the economics. So it's like we are having a digital twin of the reservoir available to us. And then for each of these digital twins, you have a polyplan session. So, for example, one or more teams could work on the same asset, or different teams can work on different, models. And based on this way, you try to go through what are your different what if scenarios. And if I drill a well here, or if I do a lot of water shutoffs, or if I put an injector in the middle of the field, or There are so many options available which you can do in real time. Then, based on that, you will monitor what are the technical and economical parameters. So, you can look at your production bubble maps, your NPV numbers. You can see how your performance is improved, maybe by putting extra perf or doing a hydraulic fracture, or you've converted a well from a producer to an injector. So, different options like this, and then you can see which way your field is leading you, basically. And ultimately, we are getting the results in the terms of net present value also. So, it's very economics based. So, MSDP provides a series of metrics which are based on your activity by activity performance. And once we have the activities for all the different model realizations, we can see which are the efficient activities, and those are the ones that we'll pick for the final development plan. So, for example, you will have one set of metrics related to financials. So, you'll talk about NPV. So, you can set, for example, a reference NPV. Maybe reference NPV is only your NFA scenario, and then you can see how the different scenarios compare to that reference scenario. You can look at your oil recovery factor. Then you can analyze how your budget was spent. So, what percentage went on producers, what percentage on injectors, what on fracturing, workovers, stuff like that. And then you can see about drilling, your parameters on drilling. So that's all the financial part. Then, as well for the producers and the injectors, you also have metrics. So you will see how many new producers you put in and drilled. What's the average oil production rate? For injectors, you can see what's the average water injection rate, and a lot of uh, metrics that are really useful for understanding the effect of your actions that you took on the field. So, for example, you can see your cumulative production on your new wells, cumulative production on old wells, your pressures, your field wide PI. And again, on the injectors, you can look at your different important parameters like PIR and VRR and bottom hole pressures, stuff like that. So these are automatically generated by MSDP at the end of the development. And so when you look at the activities and you see, okay, I got this this action was good, this action was good, this action was good. So at the end of it, we'll do a final FDP based on all the actions that were good across all my scenarios, right? And this is nothing new in the sense that uh, all FDP teams are doing it. But what we are giving is a more efficient and faster way based on economics and activity based analysis to help you get a better decision. So the key advantages are that this asset behavior is very realistic. So you have the typical geological and petrophysical and all complications, then the flow complications. You can put well integrity failure. So in the sense that if you put too high a drawdown on the well, you could create a channel behind casing. So the MSDP can account for that also. And as we saw, it could create the open hole logs and the cased hole log readings, as well as it has all the inputs on the production and the redevelopment economics. So hello, okay. Can you hear me now, guys? Okay, so uh, Okay, great. So should I go back a few slides or continue from here? Okay, so let me just go back one slide. I'm going to show you a case example. So in this case example, you're going to see three different scenarios which are being carried out on the digital twin of the field. The first scenario is the NFA, or no further action. The second scenario is going to be to expand the water flood. And the third scenario is going to be a dynamic water flood. So we'll see how we come up with the final recovery factor for each scenario using MSDP. So if we look at scenario number one, we're going to on the left hand, which is an NFA, or no further activity. So this is going to be starting in 2015. So on the left hand side, we have the recovery map, and on the right hand side, we have the velocity map. So from the recovery map, you can see that we've got fairly good recovery around this part of the on the upper left side of the field, but on the eastern side, on the southern side, there's still hydrocarbon that we can recover. And if you look at the velocity map, then you see that in the northern part of the field, there's good velocities. We're able to mobilize the hydrocarbons, but in the middle and the southern part is not so high. So let's look at it in 5 year increments. Remember, this is no further action. So for the in 5 years, we see our pressure goes down a bit, and let's go another 5 years. Um, we see that the pressure is declining quite fast. Another 5 years, we have a fairly okay sweep on the upper part of the field, but um, the lower part of the field is still doesn't have that good sweep or recovery. And as well, we can see that the velocities are not so high in the lower part of the field, right? And we see a similar scenario in, say, 2035. You'll notice that the production is pretty well just going down steadily all the while. And that's expected because we are just doing this is just an NFA scenario. So that's 2040, not much of a change. And we go another 5 years to 2045, and we find out that we have a recovery factor of like 53%. So let's go on to the next scenario. So scenario number two is going to be where we expand the water flood in the middle or in this uh, field, right? So what we're going to do is we're going to convert two producers to injectors, and we are going to open some wells that were closed. We are going to reopen. So in 5 years, you see that we managed to arrest the decline a bit. Um, in 2025, again, it's the production is declining, but it's the rate of decline is not that high. We can see that we're having good recovery from the upper left hand side of the field. Um, uh, and this is 2030. Again, you can see that now we've started to mobilize a little bit of fluid from the lower part of the field also. That's 2035. 2040 and 2045. So in this, where basically what we did was we converted like two of the producers to injectors, and some of the shut-in wells we opened to production. And at the end of it, what we see is that we get about 59% of recovery as compared to the 53% of the first case, which was the NFA. So now let's see the third scenario, which is what we say is a dynamic water flood, in the sense that after a few years we'll add more injectors, right? So we start off in 2015, which is the same, and we convert two producers to injectors, and we reopen two producers, and 2020 is similar. But what we do is that we are going to convert some of the producers into injectors in the middle part of the field. So based on this, uh, we can see that in the initial period we got a big spike of production, and then we saw the decline. But we are seeing that we're getting better recovery from the lower part of the field also, and we are mobilizing fluid from the lower part of the field. You can see that our velocities are quite even both on the upper and the lower part of the field, and our production is still quite good compared to the other scenarios. And when we go to 2045, we see that here we've had very good recovery over most of the field, just a few areas which still have oil left. And we've managed to push up the recovery factor to about 62%. So these scenarios were done using MSDP, and we were able to do them pretty fast. And that's the kind of analysis that can be done by the asset team sitting in their office and doing actions on the base map, and taking the decisions and looking at the year by year results. So the main benefits of this are, number one, it's fast and automated, because the team in the conventional workflow, the team will come up with a series of actions, then they send it to the simulation team, and the simulation team spends a lot of time going through this, then it comes back to the asset team, so there's a much more turnaround time there. But here everyone can directly interact with the model through the polyplan. You have multiple model realizations, and and then multiple scenarios on those realizations. And finally, we can also come up with an optimal surveillance program, because as we saw that polyplan can also simulate your say production logs or PLTs or stuff like that. So I think that's all I had for today's presentation. So we have about 20 minutes or so for questions. So I'll just go through the questions one by one. Okay, so we have a question. What's the minimum data input needed for MSDP? So, okay, Guru. So if you see that MSDP is using Polyplan, which is running on top of your 3D model, which is your basic simulator, right? So you need a 3D model uh, on top of which MSDP is working. So all the data that's required for a simulator is needed for this. Okay, so from Fabiola, there's a question: from where does the cost number come? Is it input or pricing reference by software? So basically, the software can provide a pricing reference, but different companies have different cost numbers because costs vary from one country to the other. So basically, depending on what are the actual costs that any company is using, because different companies, different countries, they are different costs. So we input that into the MSDP, right? Okay, so for security, basically it's very secure. It's encrypted data connection. So your study teams can be in different offices in different locations, and the server is located in one particular place, and it's like the same as the banking transactions you do, like 256-bit encryption. So it's very secure that way. Okay, so there's a question: what are the key differences between conventional FDP creating and with Polyplan? So basically, you can see that in conventional FDP, let me just go back to that slide. You can see that in the conventional FDP, you will have the same, let's say, three models: the high STOIP, the middle STOIP, and the low STOIP. And then you come up with different scenarios based on the kind of budget that you want to use. And then it's the job of the simulation team to convert your scenarios into the simulation language, and then look at the get the answers back, and then provide those answers in the correct format to the study team, right? But in Polyplan, most of this is automated, in the sense that you do need a good history match model, but the actions that you are taking for the FDP, those actions, as we saw, are done completely online. So your team will have the same scenarios, but then converting these scenarios into the simulator language from the, so these are high level scenarios: drill a well there, perforate that zone, or maybe do some fracking job, or do some stimulation. So for converting those into the simulator language and looking at the results in real time, all that is done automatically on the web based. So that's why we are saying that it saves you a lot of time. Animation team is doing the same work, but if they have to do it all, by scenario, write it into the simulator data file, so it will take much more time. Plus, here in MSDP, we are also getting different metrics with each realization, with each activity. So you're looking at the financials, you're looking at the production, you're looking at the producers and injectors, and so that's, I would say, those are the main differences. Yes, you need a history match model to use MSDPs. Okay, so we have a question from Mohammed Al Shistawi. How does it account for possible uncertainties in geological or surface data? Do we have to inform the software about uncertain parameter, or is it integral part that verifies and detect them? Um, um, in this case, as I said, we try to choose the action that has the lowest possible risk. So if we have three or four different um, mo- uh, models, but we find the same action gives good results in those models, then we say it's a good answer. But maybe someone from a Sofoil team can help me further on this. Maybe say, Vladimir, would you be able to provide some more feedback on that? Also, what I'd like to say is that we have a forum attached to this YouTube presentation. So if you have a question which you feel you didn't get a very good answer, or you would like more better results on that, then please post the question on the forum, and we will answer it in that forum also. Okay, so I hope you guys uh, were able to get some idea of MSDP through this short presentation. Do we have some more questions? Okay, well, so if there are no more questions, then we can probably um, come to an end of this. As I mentioned, there's a forum attached to this, and we can you can ask all your questions on the forum itself, and we'll be happy to get back to you with your questions and any other things. So, thank you very much for taking the time out to listen to us, and we highly appreciate your attendance. Thank you very much. Bye.